Hello and welcome to another exciting episode of Cooking with Unity. Um, I can't see my date and time up there. That's just great. All right. Anyway, um, today we're going to be continuing the uh, puzzle platformer and trying to make it work a little bit better. And last time I kind of coded myself into a couple corners and got a little frustrated, and I apologize about that. But this time we should go pretty smooth. Um, Also, first off, I am still kind of sick from this weekend, and I just had a very unpleasant weekend. And if nature calls, I may be cutting this episode short. If not, I'll go the full hour. But if something comes up, I'm not going to be able to continue the whole episode. So let's get started. So first off, I did a little research on this one and looked at different ways to go about making this a little bit better than what we had. And so what we're going to start with is changing the way our pickup system works, just so that it's easier to organize the objects into groups that can activate and deactivate each other. So what we're going to do is we're going to open up the pickup drop script and wait for mono develop to. Oh, that was fast. All right. And what we're going to change here is currently it checks to see if the collider tag is interactive. We're going to be using the tags for determining the type of the object is, rather the color in this case, but it could be the type if we were going to change it with like geometry or something. So we need to change this to actually work off of layers rather than off of tags. And it's pretty easy to set that up. So what we're going to add first is a public, what is it called? This mask something. Layer mask. All right. Public layer mask. And we're just going to call this pickup mask. And what a layer mask is a number that represents the layers that you can interact with. Unfortunately, the picker, like if I hit save here and we just look at how it looks on our main camera. We have the script twice. Okay, that's a problem. Let's just remove one of these. All right, so we have this pickup mask and it says nothing, and it's just a pull down menu, which seems right at first glance, but the problem is the advantage of layer masks is that you can combine them, so you could make an object collide with layers 2, 3, and 4, but not 5 and 1. And that isn't really exposed to you when you set up a layer mask as a public variable. I will go into at another time how to actually set that up so that you can collide with multiple layers, but it's not outside of the scope of this particular episode because we don't need any more than one layer on this. So we have our pickup mask. It doesn't actually hook into anything yet, so let's do that real quick. So there's another version of physics raycast that accepts a layer mask. It just accepts it after pickup distance. You can find this out by going physics.raycast and going through the different ones. And what we want is hit info, distance, and layer mask. So it's going to be this 12th one. But all we need to do is just add the layer mask. We're already using this for everything else. So that's just at the end here. So we're just going to add our new layer mask. So pickup mask. And now that we're checking that, this will not return true unless there's an object in the distance that you can pick it up and that it applies to the pickup mask. So we no longer have to check to see if the collider tag is interactive. So I'm going to be removing that here. And I'm going to be retabbing this. You can select a bunch of text and press tab to tab it in, or shift tab to tab it out. So I just did that real quick there. And anything else we need to change? That probably is all we need to change, actually. So let's hit save. Let's create our new layer here. Let's click on one of these cubes so we don't mess anything up. Go to add layer, and we already have interactive as a layer. I'm going to rename it to just pickup. so that you know that you can pick things up, and that's all we're going to use it for. And let's see, and then we have the tags for interactive. I'm just going to remove that. It's not a thing we need anymore. So you could leave it in there, it wouldn't have hurt anything, but I'm just going to do that so that we can be more explicit. So, oh, undefined, that's scary. Hopefully that means the same as untagged. I'm just going to untag them just to make sure. And we're going to set all these to, actually, let's set the original one to untagged and pickup. So these should say pickup now. Okay, they do. So the final thing we need is on our main camera, we set it to pickup mask on pickup. And when we hit play, everything should work as it did before. And I'm going to actually break it real quick just to make sure that we are doing this right, but it should just work. All right, so we picked it up, we drop it. Okay, so it's effectively working. So let's just make sure that it's doing its job. So let's say nothing here and see if it can pick up anything. Nope. And if we do everything, we probably can pick up everything, which we don't want, but I just wanted to make sure that all this is still happening. Yep, we can do all the craziness, although it doesn't have a rigid body, so we can't drop it properly. Not a problem. We don't need that anyway. So, oh, wait. Oh, maybe it is a map. Maybe you can select multiple things. So pick up, water. Oh, you can. It's just a really weird interface. Okay, so never mind what I was going to say. I didn't realize you could actually select multiple items. So you can use a layer mask to hit multiple layers without having to do any bit shifting or anything. So that's cool. All right, one less thing to worry about. All right, so let's make sure everything's going back the way we want. We can pick up the white cubes. We can't pick this up. All right, good enough for right now. So now let's open level 2 again. And we're going to first just make sure that everything still works. So like this object is based on, okay, it's not based on anything. So we're going to untag it again, and we're going to set it to the pickup layer, which, that's cool. It somehow already knew to do that. Maybe it's because it was originally the interactive layer. So this should work, and we'll see if the level still is completable. Oh, wait. Didn't actually change this. Actually, let's change it on our first-person controller. So it should propagate to the other levels. I guess we can just hit apply, can't we? Just apply here. And then if we go here, it should say pickup. Okay, good. So let's try this again. We have our red cube, we pick it up, we throw it in here, and it turns on the bridge. All right. So now we're going to rewire this a little bit more to make it so that each color kind of has an on-off state. So what we're going to do right now, the red trigger in this box is explicitly set up to activate the bridge. And the bridge has a little thing that allows you to change its state between two, and that's something we're probably going to use. Activated material, what were we doing here? Oh, yeah. Okay, that was to change what it looks like so that it activates. So what we're going to change is we're going to make it so if we had multiple bridges or multiple items that need to enable or disable when you put a key into a lock, it can do that easily. And we're going to use tags for that. So what we're going to do is we're going to make a tag for each color. We're just going to start with red because that's what we've got going on here. I don't know why this has changed. Let's just do 1 for right now, or 1. Has to be 2. Weird. All right. Well, we'll put a blue here too, just in case. I don't know why it automatically increments that number. Oh well, I guess it's just for ease of use or something. So we're going to put the trigger cube in the red tag. And we're going to change our activate bridge thing here a little bit. So here we go. Oh yeah, we were checking the material color. That's too strange. Let's change that. So we're going to actually tag this with red as well. So it's going to be red. And we're going to have this script use the tag of whatever object it is to compare against. So if other.tag equals GameObject.tag. And so now we have this bridge thing. We don't want to actually do that. We want to send a message to everything that has this tag. So the way we can do that is we can do GameObject.find GameObjects with tag. And this returns a list of, or an array of objects that share the tag. So we're just going to put in GameObject.tag here. And so what we're going to iterate on every object in here, so we can actually do this with a for each loop. So for each game object obj in game objects find objects with tag. And so we're just going to do obj.send message object to activate. I'm getting a problem. Oh yeah, missing a paren. So hit save on that, and then exit's going to look exactly the same, except for we're going to use object deactivate. So just paste it up here, do some sloppy copy and paste stuff, and here we are. Why is it not checking the tag? Let's double check that it's still a proper tag. All right. We're still going to have a small problem here, but we'll see if we can figure around it. That's if we have the multiple keys of the same color. I'm just not going to support that for right now. Basically, the problem would be is if you moved a red object into a goal, and then you moved another red object into the goal, and then you move one of them out, it will deactivate everything, even though there's still a red object in there. So there's ways we can get around that, but I'm just going to leave that as is for right now, and we can fix it later. So let's see if this works. This is not going to actually work just yet, but let's give it a shot here anyway. So we pick up the cube, we put it in here, and if I turn around, it says, okay, send message object activate has no receiver. So one of the objects that sent a message to, okay, so that's probably because it sent the message to our block, and our block doesn't do anything with that message. So that's actually good to have for debugging purposes, to know that a message was actually sent. If you want to get rid of errors like that, you can actually do SID message options don't require a receiver, just like this, and it'll make it so that if it doesn't have a receiver, it doesn't worry about it. And we'll probably want that because we don't want it to spam this for every object that doesn't interact. But as I said, it can be useful to have that information, so you might not want to do this until later in a project, just because you'll at least know that messages are being sent, even if they're sent to things that don't want them. So here we are. we'll try this again, and it shouldn't give us an error, but it'll still not work because right now we're not actually sending the message to the bridge because the bridge isn't part of that group. So all we have to do to change that is go to our bridge and set this to red. And now it should just work because we already have a script on there that has those functions on it. Let's see if this works. So I'm going to look over here. Oh, it turned on. It turned off. Good deal. All right, so that's working. Let's take a look at the script just in case, just to see if there's anything we don't really need in there anymore. So let's go ahead, enable collision and change material. So yeah, here's our object activate and object deactivate methods, and it also has a start method that gets its original material. We just assume that it's deactivated. We could probably do something to change that, but we wouldn't want to. In this case, we want it just to activate things that when the block goes in. They shouldn't have alternating states in this particular puzzle game. So that'll work, and that does work. So now we have this. So if we wanted to, we could have multiple objects that enable or disable when that happens. So if we were to, say, make this bridge into a prefab and then put a few more of them in other areas, you'll see that they'll all activate and all deactivate now, which is something that our previous script wouldn't be able to do because you just gave it a single object to activate. See, all of them change all at the same time. It's a thing of beauty. So let's clean up this level, get rid of these extra bridges that we made, and let's make a third level. What time is it? Why can't I see the time? Is there anything that has less? There we go. I'm gonna put this further in so maybe it'll show up. PM. All right, that's real helpful. Oh, and I can't put it further than the... Well, that's just great. I love this resolution. All right. So maybe I can change this real quick. I'll fix it later. Where are we at? I don't even know. I looked at it 3 times and... Oh, 17 minutes. We have done nothing. All right. Got a lot of time. So let's work on a new level then. Let's get rid of all these. That was a beep. Just delete. Oh, shift. Okay. Or command delete. I don't know why it's not just delete, but it's not. Alright, so let's open up level 3, and level 3 I think was a duplicate to level 2. Yeah, except for it had 2 red cubes. So let's just make another very simple example of this. So we're going to make one of these cubes have a different material. Let's duplicate this red material. Just Command D will duplicate. I'm going to make blue. And this is... I'm going to rename this to red disabled. And let's go ahead and create a folder to contain these, just so they're easier to find. This is materials. Alright, so we need blue. We need this to actually be blue, so that's easy. We just do one of these and slide it down. Alright, and then we're going to duplicate this again. And blue disabled. And it's just going to be a transparent version of the diffuse shader. There we go. Transparent, diffuse. I think that's already exactly how we want it. Okay, good. So let's duplicate one of these. Oh, and we have to tag this again, it looks like. So, sorry, I'm doing this on a touchpad, and sometimes it's a little touchy. So, this is red. This one we're going to actually change the material to blue disabled, and we're going to make it blue. And we're going to make sure this is set to red. We're going to set one of these to red. And we're going to make sure it's on the pickup layer. Same thing on this one. I'm going to call this red trigger. And we're going to call this blue trigger. And we're going to actually make it blue by just dragging that. We can drag it over here. There's a bunch of different ways you can change the color of something. We're going to set it to the blue layer, the pickup layer, and let's see, what else do we need? This is on the blue layer, right? That's on the red layer. And let's just make our bridge half size here. So we'll just do a resize on here and make it smaller. This is going to be pretty much exactly the same level. I'm just doing this for the purpose of seeing how this works now and showing how, even though we have a couple scripts here, we can just reuse them automatically. So we're going to call this red bridge. We're going to create, and we're going to duplicate it, call it blue bridge, and move it here. Going to change the material to blue disabled. We're going to change the tag to blue. And what else do we need to do? That's probably it, isn't it? Oh, wait, no, we need to check its script here. So the activated material should be blue. So I need to actually select that again, because otherwise this thing will turn red. So we didn't have to change too much, and now we have two switches that should just work right out of the box for us. So let's see. So let's first do the false positive. Try and put the red box into the blue. Oh, can't see it. Alright. Alright. Nothing happens. Let's see if we put the red box into the red. It activates and deactivates the bridge. Excellent. And then we can do the blue here as well. Alright. We got two working bridges. And let's see. Yeah, that'll work. I don't know what level this loads. Probably the first one. Yep, it does. All right, we're back to the first level. So let's make sure level 2 loads level 3. Yeah, we'll save level 3. Make sure that this thing level 3. All right, cool. So this should all work all the way through. So let's just play through our game real quick and see how this goes. So we got our stacking level. I'm gonna switch this to maximize on play so we can actually see it a little bit better, and so I can click on things easier. All right, so here we go. Gonna stack a cube. Gonna stack another cube. I think we only need to go 3 high to actually make this work, and the trick is just not pushing things away. Or not stacking them successfully. Might need to add a little reticle. I keep wanting to click where the mouse pointer is, which is not appropriate. As a matter of fact, we'll do that next. I kind of want to show you a little trick with it. Basically a way to do two cameras, so you can have a user interface camera that's pointed somewhere else in the universe and then overlay it over the screen. It's not really necessary in this case, but it'll be useful in your project, so I'm going to show it. So, final level, not much different than the previous level. All right. So, it all works. We have a game. This is a game. All right. Let's see. I mean, we could make it more game-like by having timers and other useful toys, but this qualifies right now. We have win conditions, and it's not a very long game, and it's not a very interesting game, but it's a game. So, what were we talking about? Let's do the reticle thing real quick. So, you can have more than one camera in a scene, and most of the time, you can use it for split screen. You can use it for a bunch of different special things. You can split the screen down the middle, have two cameras that are near each other, and do like a stereoscopic thing. But what we're going to use the second camera for is to draw a reticle. And so it's going to be a very simple reticle. I think it's just going to be a sphere. And we could do this just by, we could literally just attach a sphere to the first person controller, the main camera, just some point in front of it. That's, it works, but it can have little problems. Like, the sphere itself will be in the same space as the camera, so if it passes through an object, it will, you'll see it pass through the object as opposed to always drawing on the screen. And there's other minor issues that can happen with that too. Like, it might have physics enabled and bump things around, and you don't want it to, which is something you could fix. But I'm going to show you how to do it on a separate camera, so it doesn't have any meaningful connection to the scene that it's in. It's just drawn over it. So we're going to create a new camera. Where's our camera? And I'm just going to set it to 0, 0, 0. And then we're going to put it under the ground a little bit. Negative 100. So this thing's way off in an area that can't see the game area. And that's important because if it can, you'll be able to see through it. And if we just hit play here, I think you'll just see that it will just render blue. And that's not... Okay, it's rendering second, so it's not a problem. Oh, to audio listeners, let's fix that real quick first. All cameras, when you create them, include an audio listener. We don't need that. We're just going to remove that. And let's see. This one's going to be our UI camera. And we're going to place a small sphere in the middle of it. So just create sphere. We're going to call this Reticle. And 0, negative 100, 0. Actually, let's put 0, 0, 0, and we'll just attach it to the UI camera. And then we're just going to put it like 0 and 1 unit to the front or something. So Z, we'll just put 1 unit out. And if we look at our camera, we'll see that it's way too big. So we can do that by either scaling or just putting it further away. I'm just going to scale it. So let's scale it to 0.01. Let's see how that looks. And we definitely don't need a collider on here, and we do need our renderer though. So if we go to UI camera, I can't really see it now. It's probably too small. Alright, let's make it bigger. Let's do 0.1. Alright, that's probably overkill on size still. Let's just play with it first, though. So if we hit play, we don't see anything. The game's playing as normal. You have to do a couple things to our camera to make this work. So first thing we need to do is make it so this camera renders after the first camera. And the way we do that is we change the depth. And if you mouse over depth, I think it tells you how. So larger depth is drawn on a camera with a smaller depth. So if we set the depth to 1, it should render after our camera. And so now we only see our new reticle, which is not very useful to us. So what we need to do is we need to make it so that it doesn't draw the skybox over the scene. That's what's happening here, is this blue is actually being drawn on top of our previous scene. And so you just change the clear flags to depth only, or don't clear. Either of those will work. And now when we hit play, you'll actually see that we have our little sphere there. And actually, this is a good example, because you can see that the angle of the sun doesn't change on it. It's not actually part of the 3D scene. It's actually static under the ground. And so that's that can be advantageous. In this case, it looks a little strange, but we just needed it to show where we're pointed, and I'm just going to leave it as is for right now. But yeah, so what this is actually doing is it's rendering 2 scenes. It's rendering the first scene, which is our main camera, which moves around the world, and it's rendering our second UI camera and just putting that on the screen. So now we have a little idea of where we're pointed. I'm going to actually make it just a little smaller. I'm just going to make it half that size. Just 0.05 across the board. We'll see how this looks. Alright, yeah, that's a little less obnoxious. Occasionally when I click, it doesn't pick things up. It's because you have to be clicking on the screen. There's probably a way to fix that, but I haven't done the research on it right now, and it's not a major issue. So what do we got for time? I'm sorry, I have to check this like this. Oh, 8:30. We're cruising. All right, so let's make some more interesting things in level 4. We're gonna duplicate level 3, and it automatically named it for us. That's nice. And we're gonna save main level. Oh, yeah, let's actually go back to the main level real quick, because I just realized our reticle is not going to be on all the stages. So we're going to just take this UI camera, create a prefab by dragging it over here. So now we see UI camera there. And now we can just drag that into our scenes anywhere, preferably someplace where we won't see it. But yeah, so if we go into our 4th level, we can just drag. We'll hit play first, and it'll play just like level 3. Alright, cool. But we want our little camera, so we can just drag our UI camera in wherever we want. And it should just work. And it did. Alright, so we've got our little reticle. And it works pretty well, because like if I don't click, and then if I am actually touching it with the sphere, it'll pick up. So let's go ahead and keep this as is, but let's make a new type. Okay, so we don't have to just do enable disable. We could actually have different actions for this. And even though we called the functions object activate and object deactivate, I'm just going to wrangle them to do other things. So we might have wanted to name them more generically, but they can still be used generically. So let's make a moving platform that only moves when the object is activated. So I'm just going to get rid of the red on this one. Delete and delete that. And we're going to make this thing work a little differently. So we're going to first make it look like it's active right now, in that it has collision. And so we're just going to work with that. This might confuse players a little bit, so this is not the best design sense in the world, but I'm just mostly doing this to show you other things you could do with it. You can figure out your own design mentality on things to make them consistent. So what we're going to do in this case is, instead of activating, it's going to start moving. So we're going to be using a different script. We're not going to use the enable collision and change material. We're going to create a new script. And part of the reason I'm doing this is because some people expressed interest in me going into... On the last episode, I talked a little bit about coroutines. And I'm going to give you a little example of a coroutine and how to get one of those set up and what they actually do. Unlike before, where I just kind of ran through it real quick. So we're going to create a new script. This is going to be called move on activate. And yeah, so we're going to open this up and we'll see what we can do with this. So we're going to have this move, and we're going to have to figure out a way to determine how much we want it to move and what direction we want it to move, which we can do entirely with a single vector. And so that's how I'm going to set it up initially. So, like I said in the last episode, vectors have direction and magnitude. And so that's exactly what we need. We just need a direction and the amount that it could maximum move. So let's start with that. Public vector 3 movement vector, and let's also do a public float speed. Movement speed will be specific. All right, and so we're going to set up a coroutine for this that'll tween the object between its current position and the extent of the movement vector and back again. And there's a few different ways we can set this up. We're going to do this with a coroutine though. So coroutines in Objective-C, you have to have them return an I enumerator, not an I enumerable. Don't confuse those. And otherwise, you just write it like a normal function, with the exception of the return value, and I'll show you that in a second here. So we're going to do this move over time, and it doesn't have to take any values. It'll just assume things from up here. So we have a function called lerp. We don't really technically need to use that here, do we? Well, let's do it anyway. So we're going to be lerping, which is a linear interpolation. Vector3.lerp. So this takes a from, a to, and a time. So we want it to go from where it started. So we need a start position. Let's make a private vector3 start position. And on start, we're going to make start position equals transform dot position. And so now we have a start position. So start position. Let's save this so it actually auto completes for me. Start. Okay, well, whatever. Vector 2. So this will be. So we want it to move to where it would be plus the movement vector. So we can just do start position plus movement vector. I went more into detail on vectors in the last episode. You should check it out if you're not really familiar with them. And we need a time. So our time, the way that lerp works is if time is 0, lerp returns the initial from vector. If it's 1, it returns the final to vector, and if it's anything between 0 and 1, it returns a vector that's between the from and to vectors. So we need a time variable, so I'm going to call this timer and declare it now. So let's see, float timer equals 0. And we don't want just timer, we want this to actually loop. So we want, let's see, we're going to need a while loop for this. So a while loop just continues while something is true. And in this case, we're going to make a private vector, no, private bool activated. That may be a built-in name. Let's not use that. Let's move enabled. That's definitely not taken by anything internal. So while move enabled, so this would make it move once when move is enabled, because once timer goes over 1.0, it just clamps at 1.0. So that's not what we want, really. And actually, timer's not increasing right now, or we're going to add this to it, basically. Timer plus equals time dot delta time. So now this thing will increase until it's 1, and it'll keep increasing after that, but the lerp function will just ignore it. And actually, we're not using the lerp at all, so we want to actually set the transform dot position equals vector3 lerp. So we want this to repeat. So the easiest way to do that is to just check if timer is greater than 1.0f. Yeah, let's just start with this. If timer is less than 1.0f, timer equals 0.0f. So we don't have our movement speed hooked in yet, but let's see if this will work. So at the start, we're gonna start coroutine and move over time. Just call it like that. And that'll start a coroutine. And this actually will not work right now. We need this coroutine to end, and it'll continue where it left off. So basically, the way coroutines work is they have this magical thing called yield return null. There's actually a different version that you can use where you actually return a wait for seconds, which allows you to check things periodically. We want this to check every frame, so we're just going to have it do once a frame, and this will get called once a frame once it's enabled. And I'm just going to start move enabled as true, so that we can test to see if this works without the rest of the logic in here. So what this will do is when update's called on this object, it'll find out that it has a coroutine that's been registered in the start function here, and it'll call this. And it calls it until it gets to a yield return null. And when it does that, it basically saves the state of this function so that it comes back right after that the next time it's called. And so what'll happen is it'll come, what's after this is nothing. So it'll go to the while loop. If move enabled is still active, it will do the timer plus equals delta time, and it'll do all this stuff and set the position, and then it'll yield return null waiting for the next frame for it to do something again. And hopefully this will just work. Let's give it a shot. So we're going to put move on activate. Now again, it's not actually on activate yet. It's just gonna work. Did I not make these public? I did. Move on activate. Weird. Oh, movement vector does not exist in the current context. Huh. I swear I could do that. What did I do wrong here? Alright, well, let's actually explicitly send the movement vector in. I thought that it had access to public variables, but I guess it doesn't. So, movement vector, and we'll do why doesn't this just work? Alright, whatever. It's probably another problem. We'll figure it out after I try this. Move. Did I spell movement vector right? I did not. That's the real problem. Movement vector. Alright, that's the problem. So we don't have to change this around at all. So let's save it. And see if we get rid of our little problem. Just gonna hit play and see if it compiles faster. Oh god. Spinning beach ball always worries me. Hello, computer. Alright. So it compiled. That's good. Alright, so let's see. Now, okay, now we've got our movement vector stuff. So we want this thing to move along Z. So we're just going to make it, I don't know, 5 units. And we don't care about movement speed for right now. So let's see if this works. Alright, so we have this moving platform that actually worked pretty good. So this thing just repeats and moves. And we probably want it to actually move out and then back in. And we could probably make it look a lot cooler than this, but it is working, so that's good. And obviously we don't want it to be working unless it's actually activated, which I'll show you how to do that in just a second here. That's the reason that we have a little while loop check. But it is moving. And so we have a working coroutine here. So let's go back to our little thing here. And again, so what this does is the first time it runs, sets the timer to 0. While move enabled, increases the timer. If the timer's over 1, it sets it to 0, which is why it resets back. And then it sets the position to the lerp between the start position and the movement vector and the timer. And then it yields, which means that it goes on to something else. And when it comes back to this function, it starts to right back where it started. So let's, we've got a couple of problems. We want to be able to set the speed, and we want to also be able to, have it move back as opposed to just loop like this. So first let's figure out the speed thing here. We're going to have to do just some very minor math. So we want movement speed. Let's actually call it movement time. This will be the time that it takes the thing to take. And I'm going to start at 1.0f, and that'll actually be equivalent to what we're doing right now. Because what's happening is this is going over the course of a second and then repeating. We can actually time it while we're doing this if we want. But it should be about a second. Alright, so there it goes. 1001, 1000, okay. 1001, 1002, 1003. So yeah, it's about a second. Not that that's the most accurate measurement in the world, but it'll work for our purposes, and you'll have to take my word for it. This 1.0. So now we want it so if the timer is greater than movement time. So now this thing can go over 1.0. So like say we had this set to 2. I must remember I'm going to set it to 2 just so that we understand the concept. So this will go over 2, and so this doesn't work out of box just yet. So what we need is, instead of plugging the timer in directly, we want to plug in the ratio of the timer to the movement time. Now, this is already a potentially dangerous thing, what we just did, because movement time we can change, and we can change it to 0. And if you divide by 0, bad things happen. It's just a general programming thing. So don't ever let this be 0. I'm not going to check for it, but keep that in mind. If you set it to 0, you will get a problem. As a matter of fact, we'll probably do it just so that you see what the problem actually is. And now we want it to ping pong. So what's the easiest way to do that? Let's make it so there's another private bool reverse equals false. So if reverse will add to the delta time, and wait, no, if not reverse, else we will subtract from the delta time. So now, instead of resetting the timer to 0, we'll say if timer is greater than movement time, we'll set reverse equals true. And then else if timer is less than 0, reverse equals false. So what this should do is it will add to the time if it's not reversed and subtract from the time if it is reversed. And then at the end of the time, it will set reversed. And at the beginning of the time, it'll set reverse off. And this should just work. Let's actually see if it does. So what we're looking for is it should take 2 seconds to do this animation, and it should do it backwards and forwards. I have a good feeling about this. Oh, it totally worked. Look at that. It's a thing of beauty. So 1001, that still seems like 1 second. Let's take a look at it. Oh, movement time is set to 1. That's the problem. So let's do 5. Let's make it real slow. And let's also do 0 on one of these so that we can find out. There we go. So now it takes 5 seconds to get to each thing. So very slow moving platform. How are we doing for time? All right, got to wrap this up soon here. So so we have that working. We have it going back and forth. Let's make it so that it enables and disables. So we're going to set move enabled to false. And we're going to, I don't think we need an update loop at all. So what was the enable collision? So object activate and object deactivate. So we're going to, on object activate, move enabled equals true, void object deactivate, move enabled equals false. And let's see if this actually worked. So now when we hit play, it should no longer move to its position. Alright, so it's sitting there. And if we move our block into our little goal area, it does nothing. Oh, because we didn't actually tag it. So if we go to our blue bridge, it's probably not tagged. Oh, it's tagged as blue. Uh-oh. Does this have a script? Activate bridge. Yeah, that's on there. It's marked as blue, right? And this is marked as blue? Everything's marked as blue? Huh. Object activate, object deactivate. Alright, let's give it another shot. I don't know why. Let's make sure that it has its movement stuff still set. Z5, movement time 5. Let's make the movement time 3. And oh, I know the problem. So we have our coroutine here, while moved enabled. That's actually not what we want, because we want this while loop to go forever, basically. Because if we don't have move enabled, it falls out of it and it stops working forever. So we're just going to do while true, which will mean that it loops forever. So there's no way that this will ever end. And then we're going to do an if statement, which checks for move enabled. If move enabled. And then we tab these out so it looks nice. Whoops. Ah, that didn't work. I was trying to be clever. So do that, and then we want the yield to return null outside of this. We hit save, and hopefully this will work. So here's our final test here. Hopefully it'll just work. It's not moving. It is moving. It's not moving. It is moving. It's not moving. It is moving. Excellent. It works. We can just drop that in here. And I think this will load the first level again. So it's not actually in our level rotation, but let's see if it works. Oh. Huh. No collision. Probably because we don't have it enabled. Yeah. Because we had it disabled by default. So let's do this one last time. Big money, no whammies. It's moving. And here it goes. And we got to the goal. We win. We are the winners. So let's save this. Save the project. And anyway, thank you for tuning in to this episode of Cooking with Unity. I hope this was helpful. We didn't do a whole lot with this game, but I expect that this will be a good starting point for people who want to do a puzzle platformer type game. It gives you some ideas for activation, and it also shows you how to work in 3D a little bit. So give me an email at pushypixels@pushypixels.com if you liked or hated the episode, or tweet me at Drakfire on Twitter. And thanks for tuning in. Let me make this a little bit bigger. Font bigger. Oh yeah, just Command plus. That's still not big enough. Read it. All right, there we go. Contact me. Hope you enjoyed the episode, and have a good night.